right, so let's get started. So we're going to solve the absolute value equation. So to solve this absolute value equation, we want to start by getting this absolute value by itself. So we're going to subtract 10 from both sides. So on the left, I have the absolute value of x plus 3 equals 10 minus 10 cancels out, and 4 minus 10 is negative 6. Now, remember, the absolute value of something can never be a negative number because the absolute value describes the distance that expression or number is from 0. So this can't happen. All right? So we cannot have an absolute value being equal to a negative number. This cannot happen. So once we see this, we can stop and say, okay, the answer is going to be no solution. There's no need to continue on in solving this because we have the absolute value equaling a negative number. Okay? All right. Number 2. Solve this absolute value equation. And let's see. So now we have the absolute value is equal to 11. So that's okay. That's a positive number. So we're going to start by writing our 2 equations. So we have dropped the absolute value sign. 4x plus 2 equals 11. And then we have 4x plus 2 equals negative 11. So we're going to solve for x on the left. So we're going to subtract 2. So then we have 4x equals 11 minus 2 is 9. And to solve for x, we're going to divide by 4 on both sides. So x equals 9 over 4. That's one solution. Now let's take care of the other equation. So we're going to start here again by subtracting 2. So then I'm going to bring down my 4x. 2 minus 2 cancels out, equals negative 11 minus 2 is negative 13. And then to solve for x, I'm going to divide by 4. So x equals negative 13 over 4. And these are my 2 solutions. Now you can always check your work for any equation by taking your solutions and plugging them into your equation. So if we have the absolute value of 4 times 9 over 4 plus 2 equals 11. So we have 9 times 9 over 4. The 4's will cancel, and so I have the absolute value of 9 plus 2 equals 11, and that's the absolute value of 11 equals 11. Okay, that works. And then we can check the other one. So we have the absolute value. I want to use green. 4 times x, we have negative 13 over 4 plus 2, closed absolute value equals 11. So again, the 4's cancel out, and so I have the absolute value of negative 13 plus 2 equals 11. So negative 13 plus 2 is negative 11, and the absolute value of negative 11 is 11, so that checks as well. So we have verified that our 2 solutions are okay. Okay, number 3, solve the compound inequalities. Sorry. Solve the compound inequalities and write the answer in interval notation. Okay. Let's see. Okay. All right, so we're going to solve each inequality individually. So we're going to start by adding 72 on the first one. So now I have x is less than or equal to negative 80 plus 72 is going to be negative 8. Okay? All right, so now we're going to solve the other one. So we're going to add 80 to both sides. So I have x is greater than or equal to negative 71 plus 80 is going to equal positive 9. So those are the solutions, but we want to write the answer in interval notation. So we're going to put these two on one number line. So I have negative 8, and then I have 9. So let's use some colors. I love colors. X is less than or equal to negative 8. So we have negative 8 here. It's less than or equal to. Since it's equal to, we're going to use a bracket. And all the values less than negative 8 are to the left. Okay? All right. So now we have x is greater than or equal to 9. So here's 9 is greater than or equal to, so we're going to use a bracket. And we're going to shade the values greater than 9. Now, this compound inequality is an AND compound inequality. So that means that the solutions must overlap. And the overlap is your answer. If you look here, there is no overlap. So that means for this compound inequality, the answer would be no solution. Now, just so we're clear, if this compound inequality, compound meaning more than one, was an OR inequality, so it's this or that one, then the solution would be the combination of everything together. So we wouldn't need the overlap. But this is an AND compound inequality, so we must have an overlap. But this has no overlap. So therefore, it's no solution. Any questions about that? I know it's kind of hard to grasp sometimes. Okay. Number 4. So solve the compound inequality. So same thing, but it's an OR compound inequality. So we'll start by solving the first one. Okay. So to start solving for x, we want to start by moving that 18 by subtracting 18 on both sides. So I have negative, I'm going to bring down that negative 8x is greater than 34 minus 18 is 16. And so now I want to solve for x. I'm going to divide by negative 8. Now when you're dividing or multiplying across an inequality sign with a negative number, you must flip that inequality sign. So that greater than is going to turn into less than because of this dividing by negative 8. So now I have x is now less than 16 divided by negative 8 is negative 2. So that's one part of your solution. Now this other one, we just subtract the 1. So then we have x is less than 9. That's the other solution. Now let's graph it so we can write our interval notation. Because I just think graphing it helps to write the interval notation so much better. So we have negative 2 and 9. Okay, so x is less than negative 2. So here's negative 2. I am not including negative 2 because it's not less than or equal to. So all the values less than negative 2 are to the left. And I'm going to use parentheses because it's not including negative 2. In developmental math, we would use an open circle for that. But since we're in intermediate, we're going to use brackets and parentheses. Okay, so the next one, x is less than 9. Here's 9. all the values less than 9 are to the left. And then we are not including 9. It's not equal to, so we're going to use parentheses as well. Okay, so this is an OR compound inequality. So remember, for an OR compound inequality, we want to include the union, everything. We don't need to overlap. We don't want just the overlap. We want everything that's part of our solution that's shaded. So if you notice here, so yeah, we definitely want to include the overlap, but we also want to include this part here, because OR means, you know, kind of like either or. So the solution's actually going to just be from here all the way to the end in green. Whoops. Okay. Does that make sense? Hopefully that makes sense. So now let's talk about the interval. So the very left of the number line is negative infinity, and the very right of the number line is positive infinity. So to write this green interval, we're going to start with negative infinity, and you always use parentheses for infinity. And it goes all the way to 9 with parentheses, because we're not including 9. It's not equal to 9. So this will be our solution in interval notation, from negative infinity to 9. Now, just so we're clear, if this were an AND compound inequality, then the solution would be where they overlap. So they would just be this part over here. But it's OR, so we include everything. Number 5, write the equation of the line below. Be sure to use the correct variable. So we have a coordinate plane here. The horizontal axis is your x-axis. The vertical axis is your y-axis. This red line is crossing the x-axis at the point 2 at 2. So your equation of the line is going to be x equals 2. That is the equation of the line. Okay? So remember, the equation of a line, that means it must have an equal sign. Okay, x equals 2. All right, so now graph the equation y equals 1. So remember, y equals 1. It's crossing through the y-axis. And where's the y-axis? Right, the vertical axis here. So y equals 1. So let's go to 1 on the y-axis. We're going to draw a horizontal line going through y equals 1. And that is your equation. So remember that vertical lines are going to be x equals a number. Horizontal lines are going to be y equals some number. Okay? Okay, number 7. Find the x and y intercepts of the line represented by the equation y equals negative 10x minus 2. So to get the x-intercept, make y equals 0 and then solve for x. So we're going to have 0 equals negative 10x minus 2. So to solve for x, we're going to add 2 to both sides of the equal sign. So 0 plus 2 is 2 equals negative 10x. And then to solve for x, we're going to divide by negative 10. So negative 2 over 10 equals x. And let's reduce this fraction. So 2 over 10 can be reduced by 2 over 2. That's going to give us negative 1 over 5. So that's your x-intercept. If we want to write that as an ordered pair, that would be negative 1 over 5, comma 0. Okay? Let's talk about the y-intercept. So to get the y-intercept, you make x equals 0 and solve for y. So we're going to have y equals, actually I'm going to use my y equals negative 10 times 0 minus 2. So negative 10 times 0 is 0, so we have y equals 0 minus 2, so y equals negative 2. And if we want to write that as an ordered pair, that would be 0, comma, negative 2. Okay? So we have our x-intercept, and we have our y-intercept. Any questions? Feel free to just type in the chat room if you have a question. Okay, number 8. Solve the slope and the y-intercept of the line represented by the equation x plus 5y plus 1 equals 0. So if we want to identify the slope and the y-intercept, the best thing is to put the equation in slope, if I could spell, slope-intercept form. And that is y equals mx plus b. So in this form, m, that coefficient is going to give you your slope, and then b, this constant, is going to give you your y-intercept. So you want to take the equation and put it into this form of slope-intercept form. So I'm going to rewrite it here. X plus 5y plus 1 equals 0. So we want to get y by itself. So to start that, let's get the 5y by itself. So we're going to subtract x and subtract 1 from both sides. So those are going to cancel. I'm going to have 5y equals, I want to put it in this form, mx plus b, so I'm going to write the negative x first, and then write minus 1. And then I want to get it to be y equals, so I'm going to divide by 5 to get the y by itself. So divide everything by 5, so I have y equals negative 1 over 5x minus 1 over 5. So now that we have written our equation in slope-intercept form, we can identify the m and the b. So the coefficient for the x is negative 1 over 5, so that is going to be your slope. The y-intercept is going to be negative 1 over 5. That's actually your y-intercept as well. This equation was interesting because your slope and y-intercept are actually the same number, but they mean very different things. Okay. All right, number 9. Given below are descriptions of 2 lines. Okay, so, all right, we're asking a few things here. Whoops. I guess we could see the whole page, maybe. No. That's better. Okay, so line 1 goes through negative 966 and negative 1394, and line 2 goes through negative 98 and negative 6, negative 58. And so we want to find the slope of each line. Whoops. Find the slope of each line, and then answer these questions below. Slope formula is y2 minus y1 over x2 minus x1. And what that basically is saying is that you're going to subtract your y values divided by subtracting your x values. Okay, good. No, I'm glad you can hear now. No problem. And then I'm recording this whole thing, so you can watch the replay for the part that you didn't hear before. So it's all good. Okay, so let's start with line 1. So if you want to label your points, x1, y1, x2, y2. So we'll say for line 1, the slope will be 94 minus 66 divided by negative 13 minus negative 9. Be super careful with those negatives. So 94 minus 66 is 28 divided by negative 19 minus negative 9 is going to equal negative 4. And 28 divided by negative 4 is negative 7. So the slope of line 1 is negative 7. Let's get the slope of line 2. So we'll say negative 58 minus negative 98 divided by negative 6 minus negative 10. So negative 58 minus negative 98 equals 40. And then negative 6 minus negative 10, and then 40 divided by 4 equals 10. So the slope of line 2 is 10. So if the slope of line 1 is negative 7 and the slope of line 2 is 10, then these two lines are neither parallel or perpendicular to each other. Okay? Parallel lines must have the same slopes. Perpendicular lines must be opposite reciprocal slopes, which means you flip and change the sign. If you don't have equal slopes or you don't have opposite reciprocal slopes, then they are neither parallel or perpendicular. Okay. Number 10, write the equation of the line having a slope of 1 and the point 65. And then write the answer in slope-intercept form. So when you're given a point and a slope, point-slope form is a very helpful way to start writing your equation. So the point-slope form is y minus y1 equals m times x minus x1. So the x1 and y1 comes from your point, and then m is the slope that you're given. That's weird. Okay, so we're going to plug in our values. So we have y minus 5 equals m, which is 1, times x minus 6. Okay, so now this is point-slope form. Now let's put it in slope-intercept form, which remember is y equals mx plus b. So let's distribute this 1, which basically makes that y minus 5 equals x minus 6. And then we want to get y by itself, so we're going to add this 5. So we have y equals x. Then negative 6 plus 5 is negative 1. And so now we have our equation in slope-intercept form. So this first one is point-slope form, and we use that when we have a point and a slope. And then the next one is slope-intercept form. They're just different ways of writing the same equation. Okay? Okay. All right. Number 11, find the equation of the line passing through the 2 points. So now the last problem, it gave you the slope and a point. Now we just have 2 points. So we need to first get the slope. And so we know how to find the slope of a line when given 2 points. That's y2 minus y1 divided by x2 minus x1. So in this case, that'll be, let's say, -5 minus 0 over 4 minus -2. So -5 minus 0 is -5. And then 4 minus -2 would be 6. So the slope of the line that we are going to write is -5 over 6. Now let's use point slope form. I really try to write neatly on here, guys. I know it may not look like it. All right. Okay, so that's going to be y minus y1 equals m times x minus x1. Now, this is where we're going to put the slope that we found for m, and then for your point, you just pick one of your points. Doesn't matter which one it is. I'm going to pick this one because it's a 0. It might make life a little easier. Okay, so I have y minus y1, which is 0, equals m, -5 over 6, times x minus x1, which in this case is -2. So I have y, because y minus 0 is y, equals -5 over 6, and then x minus -2 is just x plus 2. And then finally, I want to distribute that -5 over 6 to put it in slope-intercept form. So we have y equals -5 over 6x, and then -5 times 2 is -10 over 6. And then let's reduce any fractions. So we have y equals -5 over 6x, and then -10 over 6 can be reduced by 2 in the numerator and denominator. So that'll be -5 over 3. And this would be our final answer in slope-intercept form. So for this one, we had to find the slope. The last problem, they gave us the slope, so we didn't have to find it. But once we get the slope, then we can use one of the points to then write the equation of the line. Why does it jump around so much? Okay, so now find an equation of the line containing the point 1, 1, and it's parallel to the equation y equals 4x plus 3. So, and then write the answer in slope-intercept form. Okay, so we're given a point, but we need the slope. Now, the way we're going to get the slope is based on this information here. So if it's parallel to this equation, that means it has the same slope. So the slope of this equation, this line is 4. So the slope that we're going to use is also 4. So m is going to be 4. And then we're already given a point to work with. So now point slope form is y minus y1 equals m times x minus x1. So x1 and y1 is going to come from our point, and then the slope m is going to be 4. So we have y minus 1 equals 4 times x minus 1. There's our slope. That's our x1 and y1. So now we're going to distribute this 4. So we have 4x minus 4. So y minus 1 equals 4x minus 4. And then we want to put it in slope-intercept form, so we're going to add this 1. So then I have y equals 4x. -4 plus 1 is -3. And this is my equation here. And you see it looks okay because the slope of the given line was 4, if this one's supposed to be parallel to it, this slope must also be 4, which it is. Okay? All right. Okay. All right, so now the equation of the line passing through the point and is perpendicular to this equation. So we need to figure out the slope of the given equation, the given line. Let's put it in slope-intercept form to figure out what the slope of this line is. So we're going to start by adding 15x. So we have 3y equals positive 15x minus 9. Then divide by 3 everywhere. So we have y equals 15 over 3 is 5. X minus 9 over 3 is 3. So the slope of the given line is 5. Our slope is perpendicular to 5. So for the slope that we want to use, the perpendicular slope is going to be negative 1 over 5. That's going to be the m that we want to use. Whoops. Negative 1 over 5. Okay? So now, point slope form is y minus y1 equals m times x minus x1. All right, so we have a point we're going to use, 10, negative 6. Negative 10 will be your x1, negative 6 will be your y1, and then the slope we're going to use is negative 1 over 5 because it's perpendicular to the equation that they gave us. So we have y minus negative 6 equals negative 1 over 5 times x minus 10. So this is our m, this is our x1 and y1. So on the left I have y plus 6 equals, let's distribute that negative 1/5, so we have negative 1/5 x plus 10 times 1 is 10 divided by 5 is 2. And then to get it in slope-intercept form, we need to subtract this 6, so it's just y equals. So we have y equals negative 1/5 x. 2 minus 6 is negative 4. So that's going to be the equation of the line with these conditions. Y equals negative 1/5 x minus 4. Okay, number 14. Find the equation of the line passing through the point 90 and perpendicular to y equals negative 3x minus 5. So this slope is already in slope-intercept form, so we don't have to do a lot of work to get the slope. This slope is negative 3, and then we need the perpendicular slope. So we're going to flip it and change the sign. So the perpendicular slope is going to be positive 1 over 3. That's going to be the m that we use to make that green. So we're going to start with point slope form. I promise I'm trying to write neat for y'all, but you know it's a struggle. Y minus y1 equals m times x minus x1. So we have a point that we can work with. So the x1 will be 9, the y1 will be 0, and then the m that we're going to use is 1 over 3. So y minus 0 equals 1/3 times x minus 9. So remember, This is our x1, y1, and this is our m, our slope. So on the left side, y minus 0 is y equals, let's distribute the 1/3, 1/3 times x, and 1/3 times -9, that's going to be a negative 9 times 1 is 9, divided by 3 is 3. So now we have our equation in slope-intercept form. Number 15, find the domain and range of the relation. So the domain is basically all of your x values. Okay? So in this case, we've got 5, 8, 5, 18, and 21. There's no need to write numbers more than once, so we have 5, 8, 18, and 21. You just literally type in the numbers in the x values. Then the range would be all of your y values. So we've got 2, 9, 15, 19, and 25. 2, 9, 15, 19, and 25. Okay? That's it. Yeah. So 16, find the domain and range of this relation. Write the answer in interval notation. Okay, so like I said before, the domain is your possible x values. Why does that look like that? I'll write it down here. And then your range is your possible y values. So for domain, let's look from left to right. So going from left to right, and it's almost like, let's see, can I insert something? Let's see. Yeah. So if we go left to right, this graph starts at 1, right? And then it has a dot over 1, so we're going to use a bracket. And your graph starts at 1. We're talking about our x values. And the x values, the graph covers all the way to 3 on the x-axis. So the interval for your domain would be 1 all the way to 3. Now, we're not going to include 3 because it's an open circle. So we're going to use parentheses. So this is the interval describing the domain of this relation. Okay? And you always think left to right, smallest to largest. Now let's look at the range. So bottom to top. Okay, so starting from the bottom, it starts at -5. So this is where your range starts, but it's an open circle, so we're going to use parentheses. And then it goes all the way up to 4. The graph ends at 4 on the y. But it does touch 4, so we're going to use a bracket. Oh, hold on. We are going to use a bracket. And that describes the range. So I'm going to take a pause. I'm still here, but I want to see if you have any questions, because I think this is probably the more difficult concepts. So I want to make sure we're okay with this one. Just tell me yes or no. We're good to go. Okay, my battery's about to die here. Let me plug this in. That would be a disaster. Oh, let's see. Okay. Great. Okay. So one more time. So your domain is referring to your x values. So left to right. So the blue is what we're looking at. So for your domain, think about, and here we'll do, let me do another one of these. picture. I want a shape. Okay. So the domain is referring to my x values. I'm going to use this to kind of help you focus on just the part we want to focus on. Why? Why is it not moving? Okay. All right, so the domain is just the x values left to right. So it's starting from -1. Oh, that says +1. That should be a negative. Okay, so it's going from -1 all the way to 3 for the x values. Okay, so that's why our domain is 1 to 3, and that's why it's a bracket at -1 because it's a closed circle, and it's a parentheses at 3 because it's an open circle over x equals 3. And now for the range, it's your y values. We're going to flip these over. Okay, so let's just kind of mark it so you can only focus on the y values. So now it's starting at -5 all the way up to 4. And so we're going to use parentheses by -5 because it's an open circle, and we're going to use a bracket by 4 because it does touch 4 there. Okay? All right. Move those out the way. Okay, 17. Let's practice one more time. Find the domain and range. So these graphs in MAT1033C look weird for some reason. That's why we have that extra kind of note here. So assume there is an arrow if the relation exits the graph. So what that means is that think of that as an arrow. And then also assume that the endpoint is an integer. That basically means that the endpoint is right there at 2, -4. Okay, so domain. So we're thinking left to right. So if we travel along the left, it's starting at what x value? Right here at 2. So it's going to go from 2 all the way to infinity. Because it's an arrow. Going on and on to the right like that. So we're going to use a bracket by 2 because it's a closed circle. It's an endpoint, and it is an integer. And then we always use parentheses by infinity. So that's your domain. Now let's talk range. So we're going to start from the bottom for range. So from the bottom, it starts at -4. And we're going to use a bracket because it does have an endpoint there. And it's going up. So the arrow is going all the way to the right and then all the way up. So that's going up to infinity with parentheses. Okay? All right. 18. Find the domain and range of this relation. So, and this one's also telling you assume there's arrows on both ends. Okay, so for the domain, remember it's all of your x values, think left, right. So from the left, so our arrows are going out to the graph to the left, and they're going out to the right. So that means that it has all the possible x values in the real number system. That's going to be all real numbers, or in negative infinity to positive. That's your domain. Now the range is your possible y values, starting from the bottom. So it's an arrow from negative infinity, and it's going all the way up to +1 on the y-axis. And then it doesn't include 1, so we're going to use a bracket. If it was an open circle here, then you would use parentheses. All right? Okay. Another domain. So I had a few examples of these because I know these are kind of harder to understand. Find the domain and range. So again, we're going to assume arrows. For whatever reason, IMAT doesn't like to put arrows, so I had to put that little note there for you. So for the domain, this is another one where you have all real numbers. It's going from negative to positive infinity, because from the left, the arrow is going to keep going. So basically it means it keeps going on and on and on and on, and keeps going on and on that way. And then for the range, you always start from the bottom. So as you can see here, it's starting from the very, very bottom to negative infinity. And it's going all the way up to what y value? Positive 1. And it does touch at 1, so we're going to use a bracket. Okay? All right. So 20, determine if the relation is a function. So for this problem, we're going to kind of list the domain and list the range. Short answer is if any of your x values repeat in your set like this, then you know it's not a function. Let's just list out our values. So we have 12, negative 16, 11, negative 15, and then 11 again. And then for the range, we have 5, negative 12, 3, 6, and negative 4. So let's draw a mapping. So 12 maps to 5, negative 16 maps to negative 12, 11 maps to 3, negative 15 maps to 6, and then 11 maps to negative 4. So we cannot have one input or one value in the domain produce two different outputs. So because we see this here, 11 is repeating in the domain, this means it is not a function. And the whole idea of a function basically means that it's like something where if you input a value, it will produce one output. Okay? Now, different inputs could yield the same output. That's okay. But one input, one domain cannot yield or produce two different outputs. So basically, if you see a domain or input or x value repeating, then it's not a function. All right? Now we're going to look at it on a graph. Select all the following graphs that represent the graph of functions. So what that looks like graphically is that if you do what's called the vertical line test, there should never be anywhere on your graph where it crosses a vertical line more than once at the same time. So like if I were to, and I'm going to just draw a nice fat line. Okay. All right, so let's use this as our example. All right, this is our vertical line. There's nowhere when I cross this graph, this parabola, that it crosses this vertical line twice at one time. So this graph, sorry guys, this graph here is a yes. That's a function. Okay, let's look at the next one. All right, that's like a sine or cosine function. So no matter where I am along the graph, it's not crossing it more than once. So this one would also be a yes. Okay, the next one, the graph is here. It never crosses that vertical line more than once. So this is a function. Let's look at the next one. Now this one is not passing the vertical line test. Look here. On that vertical line, 1, 2, 3 different times. This would not be a function. Okay? Because it is not passing the vertical line test. Let's do this one. That is passing the vertical line test, not crossing that graph more than once. And then the last one, this circle, is definitely going to fail the vertical line test. On that vertical line, it crosses that graph twice. so this would not be a function. Okay, and what it is saying this input of, say, -1 is yielding two different outputs. It's giving you this x of -1 is giving you a y of 0 and a y of 2. That doesn't create a function. It's a relation, but not a function. Okay? All right. The function f of x equals x squared minus 6x plus 3. Find f of -2. This is basically having you to practice interval notation. So we're going to, all this means is that we are going to plug in -2 everywhere we see x. So that's going to be -2 squared minus 6 times -2 plus 3. So everywhere we see x, we're plugging in -2. And then we're going to follow our order of operations. So we're going to use, do exponents next because there's nothing to do within the parentheses. So -2 squared is -2 times -2, which is positive 4. Let's bring down everything else. Next we're going to do our multiplication. So we have -6 times -2 is positive 12. So we have 4 plus 12, it's positive, plus 3. And then now we have addition, so we can just add left to right. So 4 plus 12 is 16 plus 3 equals 19. So f of -2 equals 19. Okay? Using the graph of the function f of x, find f of 1. What this is basically saying is that when x equals 1, find y. Because f of x, I don't know why it does that there. F of x is the same thing as y. So that's what this statement is basically saying. When x equals 1, find y. So let's look at when x equals 1. Here's the x-axis. This is when x equals 1. Okay, my graph, okay, my line is real suspect, but we're going to just try to draw a straight line. So when x equals 1, my graph is right, oh goodness, where'd it go? My graph crosses right here, and the y value is 3. So f of 1 equals 3. So when x equals 1, my y value is 3. And my graph, this shape here, crosses at x equals 1 in only one spot right here. So that's why the answer is just 3. Okay? All right, so now find the domain of the function. So we have a couple examples of this. So algebraically, to identify the domain, you got two scenarios you want to look out for. One scenario is if you have a denominator with a variable in the denominator. We never want the denominator to equal 0. So if there's ever a chance that the denominator could equal 0, we want to exclude those values from the domain. Then the other scenario is if you have a square root. You never want there to be a negative number under a square root because that would give you an imaginary number, and we're not talking about imaginary numbers right now. So you want to exclude any values that would make the radicand, the number under the radical sign, negative, a square root, a negative. If you don't have either of those situations, then it's all real numbers. So like here, f of x equals -6x squared plus 2x plus 8. So you don't have a square root, and you don't have a denominator or fraction bar with a variable in the bottom. So the domain here would just be all real numbers if we want to write in interval notation, we would say negative to positive infinity. And that's it. Now let's look at another scenario. Now, find the domain of this function. H of x equals 46x over negative x minus 12. So we have a red flag here. We have a denominator and it has a variable. So that means there could be a way the denominator can be a 0, and we don't want to include that in the domain, because if we have 0 in the denominator, that gives us a undefined answer. So what you want to do is you want to set that denominator equal to 0, figure out when that would happen, and exclude those values, remove those values from the domain. So if we make this equal to 0, what would x have to be to make negative 6x minus 12 equals 0? Let's solve it. So we would add 12. So we'd have negative 6x equals 12 divided by negative 6. So x equals 12 divided by negative 6 is negative 2. So for the domain for this function, so if we think about it on a number line, if we didn't see what's in the red that I circled, it would be all real numbers. Everything here would be the domain. But that's not true because we want to exclude negative 2. So we don't want to include negative 2 there for our domain. So everything except for negative 2 is the domain. Because if we include negative 2, what happens to the denominator? It equals 0. So this is the graph of our domain. Now let's write it in interval notation. So we have two intervals here. We have this interval and then this interval. So the first interval starts at negative infinity and it goes all the way to negative 2. But we're going to use parentheses because we're not including negative 2. And then we're going to do the union symbol. And then the next interval starts at negative 2 with parentheses and it goes all the way to infinity. So this would be your domain in interval notation. So you have to find out what value to exclude from your domain so you can figure out what the domain would be. Okay, then the other scenario is if we have a square root. So you don't want a negative value under a square root. That's going to give you an undefined answer. So to get the domain of this type of function, let's take what's under the square root and let's set it greater than or equal to 0, because this would be okay. This would be okay. So if we solve that, that will actually give us the domain. So we will solve for x by adding the 8 because we want to get x by itself. So we want to get that term with x by itself. So we have negative 2x is greater than or equal to 0 plus 8, which is 8. And then we're going to divide by negative 2. And if you divide or multiply across an inequality by a negative, we have to flip that inequality sign. So we have x is less than or equal to 8 divided by negative 2, which is negative 4. So that's the domain in set builder notation. Let's do that in interval notation. So we have negative 4. All the values less than negative 4 are to the left. And then we are including negative 4, so we'll use a closed circle, but let's also use a bracket because we're in intermediate algebra. We're using brackets and parentheses. So that's how the graph would look. Let's write that interval. So we're going to start with negative infinity. Always use parentheses for infinity. And it goes all the way to negative 4. And we're going to include negative 4 because it's less than or equal to. So this would be the domain of this function f of x. So just work through an entire test review. Now your actual test is just 20 questions. So some of these problems that I gave you multiple examples, it's because I wanted you to see multiple examples. But your actual test is just 20 questions. So your test review is set to where you can do it unlimited times. Each question is going to give you a different Each time you attempt a question, it's going to give you a different version. But if you have one attempt, if you get it wrong, you get the answer, and then you have the option to attempt another question. So you can keep attempting as many times as you want to improve your overall score. And then your unit test review, all of your test reviews are lab grades. So you know, you have the opportunity to get a 100% lab grade. You can work on them in the depot. You can get help. Just remember, this is the best way to practice for your Unit 1 test. So yeah, so that's the whole review. You can use a graphing calculator on this test, so please get comfortable with using that. And I will be, you know, online this week. Send me an email if you have any questions. And I'm here in the depot if you want to stop by and say hi. But if there are any other questions before we log off, so I'll give you a sec and see if there's any questions before we log off. And thanks for bearing with me. This was a busy day randomly, so I had to kind of stop and handle some things. But I'm recording this, and I'm going to cut out all that, you know, dead space, and I'll post this for you to view within an hour or so. So I don't see any questions, so I'm going to go ahead and sign off, and I'll also save the notes that we have here as a PDF, and I'll post it in the class as well. All right, great. So you guys have a great rest of the week, and the test is available in the testing center. And the deadline for the test is, I don't remember at the top of my head. Where is my calendar? January 28th is the deadline to take this test. All right. Please keep in mind of your testing center's hours of operation. I know at the Osceola campus it closes at 8. You cannot start a test after 7 p.m. So I wouldn't even push that because you get 2 hours for it. So I wouldn't start it no later than 6 p.m. Okay? So yeah. So I will see you guys online, and it's been great working with you guys. Bye.